Alright, first video uploaded here is 3.3, adding and subtracting rational expressions. Those of you who were in class yesterday, that would be Monday, you would have been here for this. But those of you who weren't, here's the notes for 3.3. So when we're talking about adding and subtracting rational expressions, we're thinking exactly the same way as we do with fractions that we're used to since grade 7 or 8. When we're adding fractions, we want a common denominator, and so when we're adding rational expressions, we want a common denominator as well. So the first section here in the notes, I have when denominators are the same, and so there's the case where if denominators are already common, if we already have a common denominator, then we can just add or subtract the numerators. If the denominators are different, we'll talk about that later down in the notes. So to start out here, when denominators are the same, we have our first example, and you can see that we have a denominator of n in both expressions, and so we know that the denominator is going to be n when we're done. So since the denominator is n, the common denominator, that our final result will have a denominator of n as well. In the same way that when we're subtracting, let's say 4/5 minus 2/5, we know that we're going to have 2/5 left over, 4 minus 2. Our denominator is still 5. And so when we have a denominator of n, like in our question here, we know that the denominator is going to be n when we're done. So we will write it all over n, and then we can show the subtraction, what's happening in the top of the expression, in the numerator. And you notice that we're going to subtract the entire second numerator, so the m plus 1 from the second expression, that's all getting subtracted, and that's why we have it in brackets. So that when we do subtract, and you wouldn't need to write this next step, but I will to show, when we do subtract, we're actually subtracting m and we're subtracting 1. Because of the bracket, we distribute that negative sign into the bracket. So m minus m is 0, and then we're left with a negative 1 on top and an n in the denominator. Now, that's simplified. At this point, we could look to simplify and reduce the fraction, but we don't have any common factors top and bottom that we can cancel out, so that's our simplified expression. We also do, if you look at the question itself, we do want to identify the non-permissible values, like we have been doing. And so we're looking in the denominator. The only denominator we've ever had in this question is n, and so we know that denominator then cannot equal 0, so n itself cannot equal 0, and that's for our non-permissible value. Moving on to question 1b, example 1b. You notice again we have a common denominator already, and that's what we're dealing with in these questions, this first example. So our denominator is going to be 4n minus 3 when we're done the question, just like in the last example. So we're going to write that all over 4n minus 3. So our numerators get subtracted then, all over that common denominator. 10n minus 1 minus 8 minus 2n. And again, we're subtracting the entire second numerator, so I'm putting it in brackets to make sure that we're subtracting 8, and we're subtracting negative 2n. And so I'll show that in this next step. You wouldn't have to show this, but we will, just to make sure that it's clear. So we have everything ready to combine in the numerator. And so we do that, we get 12m minus 9, and that's over 4n minus 3. So, same point as last question, where we subtract, we combine the numerators all over that common denominator. Like we said last time, though, we do want to make sure that we're simplifying our expression as much as possible at the end. So in this case, remember, we cannot do this. This is not possible to do because we're not canceling out entire factors. We're only canceling out portions of factors there. So we're not going to do that. What we can do is we can factor and simplify. Remember, we can only cancel out entire factors. So we factor the numerator. We see that it has a GCF, a common factor of 3. And so our factors on top are 3 times 4n minus 3. So here we can see that the 4n minus 3 factor, that entire factor, can be canceled, leaving us with just 3 over 1, or 3, as a simplified expression. So we simplified our expression as much as possible, looking to reduce the fraction in the end. Once we have that value, again, we're looking at non-permissible values. And so the only denominator we've ever had here is 4n minus 3. And so you can just write the value itself, but just so we can see how we get the non-permissible value from that expression in the bottom, 4n minus 3. We add 3 on both sides, and then we divide both sides by 4. So that we know that m cannot equal 3/4. As a non-permissible value, m cannot equal 3/4. So there are 2 examples dealing with adding or subtracting rational expressions when the denominators are the same. The first question in the assignment that I'll post I'll also deal with denominators when they're the same. When denominators are different, so looking at the next half of the notes here, the next type of question, I guess, when denominators are different. You remember from what we talked about before, or even with fractions from previous courses, is that we need a common denominator. And so if the denominators are different, we need to know how we can get them to be the same. So the way we'll do this is we'll factor both denominators, and then we're going to multiply each denominator by what is missing from the other one. So we'll show that in this next example, example 2a. We have a denominator of p squared minus 1 and a denominator of p plus 1. And so what we want to do is we want to see, okay, what's our lowest common denominator? So what's going to be a denominator that will feature factors from both of these denominators already? And so what we have in our left expression is a difference of squares. And so we can factor that as p plus 1 and p minus 1. And in the other expression, we just have the p plus 1. It can't be factored. But now that we've factored, we can see that we're very close to a common denominator in both expressions. It's just that the one on the right doesn't contain a p minus 1 factor. So in order to enable it to have that factor, we multiply that denominator by p minus 1. But if we multiply the denominator by p minus 1, we have to multiply the numerator as well. So we multiply the denominator by p minus 1, and we multiply the numerator by p minus 1 as well. So we do that math there, and we now know that our denominator is going to be common denominator. So just like before, we can write it all over that common denominator, because we know that's going to be the denominator in our simplified result. So then we have the 4 from the left expression plus the 3 times the p minus 1 from our right expression. So that p minus 1 is multiplied by 3. Now, you might be looking at this and wanting to cancel out these p minus 1s now, but remember, you cannot do that because we're talking about addition in the numerator still. We have to cancel out entire factors, and there's still addition in the numerator. So we have to simplify the numerator then. We have to get rid of those brackets, multiply in the top. We'll leave the factors in the bottom. And then combine like terms in the numerator. So 4 plus 3p minus 3, we can combine 4 minus 3 is positive 1. So what we have then in the numerator is 3p plus 1. We cannot do any factoring with that. No common factor there, so that's the way it stays. This is our simplified expression. You could multiply the two factors in the denominator. However, in some questions, you'll have up to 3 factors in the denominator at the end, and it's unrealistic to spend the time of multiplying all 3 factors together. And so because of that, we won't even factor or multiply it when there's 2 factors. We're going to leave it the way that it is. You can multiply if you want to, but you can also leave it the way that you see here. So, non-permissible values. Again, we look at our denominators, what factors we had from the beginning, and all we ever had was a p plus 1 and a p minus 1. So then p cannot equal negative 1, and p cannot equal positive 1. And you can list those, or you can write plus or minus 1 if you want. All you really have to write is the values themselves, but we're just showing how to get them. So the next example then, as we look at it, we see that the denominators are more complex, but we follow the same procedure. Factor both denominators and then multiply each one by what's missing. So in the numerator, we're going to leave that as x minus 1, but in the denominator, we have factors of x plus 3 and x minus 2. And in our other expression, we have factors in the denominator of x plus 3 and x plus 1. So if we're looking to see how to get a common denominator, we notice that the left fraction, the left expression, is missing an x plus 1 in the denominator. Because there's an x plus 1 over here in the right expression, and so we need an x plus 1 in the left one as well. So in the denominator on the left, I'm going to multiply the denominator by x plus 1, and then the numerator by x plus 1 as well. So if we look at the right expression in the right denominator, you see that we have we're missing an x minus 2. There's an x minus 2 in the left denominator, so we need to make sure there's an x minus 2 in the right denominator as well. And now we see that we have an x plus 1. So we have an x plus 1, we have an x plus 3, and we have an x minus 2 in each denominator. So our denominator now is common. So we can write our next step with a denominator, one single denominator with these 3 factors. So we know that's going to be our denominator in our simplified expression. So we can write our next step all over that single denominator, because now we have a common denominator. In the numerator, you can multiply these already, but I'm just going to show the multiplication that needs to happen. So x plus 1 times x minus 1, and then minus x minus 2 times x minus 2. So again, we can't simplify yet. We can't cancel anything top and bottom because we do not have only factors on the top. We can see we still are subtracting here, and so we can't actually cancel because we're not dealing with only multiplication in the numerator. So we will have to simplify in the numerator, multiply and combine like terms. And you notice that I placed the second product here when I multiplied x minus 2 times x minus 2. I placed that in brackets because we're subtracting the entire expression there, so we want to make sure we're minusing each term, and so we'll show that in the next step. And now we can actually combine terms in the numerator. We see the x squareds cancel, x squared minus x squared, and we're left with 4x minus 5. So at this point here, we look to simplify if we can, but the numerator cannot be factored, and there are no 4x minus 5 factors in the denominator. So this is our simplified expression. And once again, the denominator, you could multiply those factors together, but multiplying 3 binomials like that together, it would probably take you about a minute to do that, and you end up with 6 terms. It's just not necessary to do. So we leave it with just the 3 factors like that, and that's fine for us. We're calling that simplified. Now the non-permissible values, if you look at the question, those are the only 3 factors that we've had throughout the entire question, so that's where our non-permissible values will come from. We have an x cannot equal -1, x cannot equal -3, and x cannot equal 2. And there are non-permissible values. So that would be the examples, the notes for 3.3. If you do have any questions, we'll find a good way to communicate. Right now, email will be the best way to do that, and I'll also give some notes on this on the Google Classroom regarding kind of the process from here on out.